Welcome everybody back to the American Space Museum Stay Curious program. I'm Marquette and we're here with Steve Kane. This is part 2. Sorry for the interruption, but we were just talking about STS-93 in 1999 having a glitch or a blurb in its electrical system, and we got kicked off the internet somehow here. But glad that Steve Kane's with us. This oral history is part of what we are bringing to you many times a month, oral histories of space workers and a few astronauts, made possible by the Marie Louise G Endowment that we're so grateful for, because they allowed us to buy some equipment to do things in a more professional way. I was just talking to Steve Kane about the wiring on a space shuttle, and STS-93 had a screw that was in the wiring and basically short-circuited one of the engines, right?
Well, engine controllers.
It was an engine
they were called
control.
MECs, main engine controllers.
And it was an abort to orbit, all right,
Correct.
which was the last stage before you don't orbit.
Right,
Okay.
before you do the return.
Before you gotta land somewhere in the world, and usually that spot was going to be over North Africa or South Spain in there. So, but tell us a little bit about the wiring. And that's what we've had here in front. Here is the orbiter piece of that wiring that explain how not complicated, how extensive this wiring job was, and how many miles of wiring are in a shuttle.
No,
Remember?
There's probably 700 or 800 miles of wiring in a shuttle.
800 miles of wiring in a space shuttle.
And Columbia especially had more wiring than the others because it was a test vehicle. So it carried a lot of additional wiring.
The maiden one of the whole program.
This wire is made out of Kapton. You know, it's a Kapton wiring is what it's called. So it has a very fragile insulating.
Now we know
layer.
Kapton from the foil that was on the lunar module.
Correct. And they began manufacturing wire out of Kapton to reduce the weight. Teflon is a lot heavier.
Mm-hmm.
So Kapton made a lot more sense from a weight characteristic, but it made it very fragile. And when the screw went into the wire bundle, it shorted, knocked these offline. And what that did was kicked off an investigation of the vehicles, because they'd always had anomalies on flight, different things that were wire related. We discovered, a couple of things in the way that the wires were laid out when the orbiters were built. But the other thing that we discovered is that they were essentially built by system. And when you take a piece of wire and you cut it flat, you create a blunt edge. And as you pass this through wire bundles, as you're adding a system to the vehicles when you're constructing them, those blunt pieces damage the Kapton and adjacent wiring. So one of the things that occurred after this event was the shuttles were essentially grounded until we were able to, essentially ascertain exactly how extensive this was. So we ended up actually with Discovery, while this was occurring, Discovery was slated for its orbiter maintenance modification period at Rockwell in California. USA had a proposal into NASA to do the work here at the Kennedy Space Center. That was accepted. It saved NASA quite a bit of money. They didn't have to transport it out there. So one of the things that occurred on Discovery was once we discovered what had happened with Columbia, is we began an extensive wire inspection effort as part of this orbiter maintenance modification period. And actually, we ended up doing wire inspection probably 3 times from end to end on all 800 miles of that wiring, or as much as we could access. A lot of it wasn't accessible. We had to inspect a lot of it with borescopes. But the areas that we could inspect, what we discovered is just what you were mentioning earlier about, the technicians accessing the different areas in the shuttle, created a lot of this damage because they were access areas. To get to a lot of the equipment that needed to be maintained, you had to go across these. You had to bring equipment across them. There were a lot of different reasons. But the maps that were generated as a result of the inspection efforts showed that the majority of the damage occurred in ingress-egress areas of the vehicles.
Oh, really?
So there were a lot of things that came out of that. We replaced a lot of wiring. We re-insulated a lot of wiring. We replaced a lot of connectors. Just a lot of tremendous effort to bring those back up to speed. But it was my understanding that after all of those efforts were done, a lot of those spurious anomalies that occurred went away. In the later stages of the shuttle program, they just didn't have those anomalies like they did in the early days. So
Yes, that was
interesting
the first third of the whole program. 99 is July 99 is when this flight Steve's talking about that Eileen Collins commanded. And then they did fly Discovery in December, 5 months later. And that was the third Hubble service mission. So that was an important one to get off there. And then that was right, Steve, right when we started flying ISS missions. Okay. The construction of the International Space Station starting in 1999 in this era.
And then
with
we sat down for
Bob
a
Cabana
couple
taking
years.
up in 98 the first, or May of 99 the first elements of
Yeah,
it.
we actually sat down for a couple of years and didn't fly because of a lot of the anomalies, and until that filtered out.
Yes.
I'm not sure what those dates were, but there was a period of time, there where we didn't fly.
So it's like rewiring your whole house, discovering you got to rewire everything in your whole house. No
Or at
big
least
deal
look
for
at
a
it.
house unless you live in a mansion, but these shuttles are mansions, so that was a lot of material expended and a lot of just scrapping out. And you have a
of
piece of
inspection
that
hours.
wire.
I do. Now, this was a plaque that was.
Hold that there for Marty, please.
This is a
too,
plaque
zoom
that
in.
was presented to the people that worked on the inspection effort. We worked really closely with the orbit electrical engineers who were responsible for the wiring and developing the inspection methods that allowed that process to be performed.
And the wire's green, of course, Marty and Jessica. Yeah, green. Well, on our green screen, but right under Steve's name here, that's where the wire is. That's it.
Yeah, it doesn't show. Yeah.
Yeah. Yeah, maybe tilt it forward there. There you get a little bit there. But one of the little mementos as space
Yeah,
workers
this
get
was
along
kinda
the way
nice, yeah.
from United Space Alliance there for a good job doing all that. It was a tremendous team effort, obviously.
Oh, it was. Yes, it
And
was quite an effort.
and then flying the shuttle for another 12 years. Like you said, you didn't have these little anomalies that you thought had gone in
It
there.
was interesting. Toward the end of the program, it used to be that it was difficult to get the orbiters complete and ready when the payloads are ready. There was always a rush to do that. Toward the end of the program, it was more the orbiters were ready, and we were waiting for payload. Because all of those processing problems, over the course of the program were resolved.
A smooth flow on your integration charts, as you guys put it in there, and
Yep,
so
kicks.
forth. Yes. Well, we're enjoying talking to Steve Kane here, and about to end our little conversation. But I wanted to ask, Steve has been in all of the major facilities on our Space Coast, from the Astrotech, where the clean room here on the coast, to Blue Origin. You've been in their facility, SpaceTech's. Give us kind of your overview of we know what's happened. Private space industry has saved the Space Coast, basically, financially, with the good jobs and homes hard to find, and our infrastructure is getting built up better.
Yeah.
But your observation working as a NASA contractor and then dealing with the private entrepreneurs out there, what's your take on that, Steve?
Well, I think what we're seeing is a complete paradigm shift in how we get things, people, materials, equipment into orbit. The space shuttle orbiters were a good space truck. They allowed us to work, take the lessons learned from Skylab and the other previous missions, Gemini, Apollo, all the lessons learned from that, went into the shuttle program. The shuttle program allowed us to take things into orbit. We learned how to work in orbit, but we really learned how to work in a different way when the International Space Station was created. That then showed us how we could actually live and work in space. And I think as we move forward, these new space companies, SpaceX, Blue Origin, Viaspace, some of the others that are producing launch vehicles now are going to take it a step further and allow us to do even more in space. I see private space stations coming. The ISS has a limited life. Eventually it won't be able to sustain. And at that point, the commercial space companies, I believe, are going to step in and take on a lot of that role. There's a lot of work that can be done in space. It's a tremendous manufacturing environment. And we work with a couple of other entities. One is actually he worked with SpaceTech for a period of time. He's in Jacksonville. I worked for his brother when I was working the quality engineering area at USA. His name is Larry Harvey, and Larry works for, he now is director of an organization called CAST, and it's the Center for Applied Space Technologies. And what their role is integrating life sciences experiments from the Mayo Clinic in Jacksonville into launch vehicles that can then be taken to the space station. And so it's interesting to see how all of that work is occurring, and that's all transitioning to commercial space as well. So, there's tremendous opportunities there for companies. I think they're solving, the cost of access to space problem that has really stopped a lot of companies from getting involved. There's so many launch vehicle providers now, and I think we see with Turan Global building the satellite processing facility here, or satellite manufacturing facility, that there's a huge backlog of equipment and capabilities that need to be flown into space. There's a lot of aging satellites that are eventually not going to be working anymore. There's some defense issues with those large monolithic satellites in that they're hard to defend. Smaller satellites and more smaller satellites, multiple satellites is much more, I guess, conducive to operations in space.
Quick access to replace
even
those
with a limited
satellites.
space life, they can still burn up upon return, and be replaced relatively easily. Everything has scaled down. The size of equipment is much less. Semiconductors have continued to scale down in size, and so all of that has led to, I think, where we are now. And it seems like every 10 years there's a huge leap forward, and I think we're going to see that going forward. It's just going to continue.
How about these facilities themselves that you've been in? I've not been in Blue Origin's facility. You've been in a lot of the space centers or manufacturing facilities around the country. Are they cutting edge?
They're absolutely cutting edge. A good example is Airbus OneWeb satellites over here in Exploration Park. They're an Industry 4.0 manufacturing facility. And for those of you that don't follow Industry 4.0, this was a manufacturing concept that actually began in Germany. And it's fully automated facility. They use smart tools in that the tools are set up by a machine. The torques are set, the operations, the attachments that are required on the tools are set by machines. Technicians operate them, obviously, but it takes a lot of the human error component out of it. So it involves not only automated manufacturing, but the Internet of Things, where everything is communicating as a system. And it's kind of the way of the future. It allowed Airbus OneWeb satellites to, what normally took a company like Lockheed Martin or some of the other, Northrop Grumman or some of the others that built these large satellite structures, it allows them now to mass produce these. Airbus OneWeb satellites can produce about 4 satellites a day in their facility. So it's really allows, and these are a lot smaller. Of course, they're refrigerator-sized satellites, so they're a lot smaller than the large, payload bay filling satellites that we were used to seeing. But they're going to continue to get smaller, and which allows, I guess, more of them to be launched as well. So.
Well, how about the manned spacecraft situation there? Inspiration 4, I mean, SpaceX has got the corner now on our access to the International Space Station. Elon Musk keeps poking Jeff Bezos in the ribs every chance he can to when's he going to build an orbiter. But I think Bezos' impact is going to be seen in the next 2 or 3 years.
I do too. The New Glenn rocket is going to be the largest rocket ever produced.
This is huge rocket.
It's a
the
massive
New
rocket.
Glenn, 18 feet in diameter. Most of them are around 14 or 13, aren't they?
Yeah, and the manufacturing facility at Blue Origin, state of the art. It's a fully state of the art facility. I'm sure Turan Global, when they build their manufacturing facility, it'll be the same. These companies have invested a lot here to do this, and the reason they have is because they know that there's a great opportunity, to take this commercial. Of course, NASA and the Space Launch System has a place as well, because NASA, when they operated shuttle, they kind of got away from their mission, which was to do the hard things, and they focused on operating the Space Shuttle program at tremendous cost, and it drained their resources. And being able to move away from that operational environment and into more of the type of work that they're doing now with SLS, I think is the right way to go, for that space agency. So I'm really excited to see what's going to happen with Space Launch System, with, building the gateway, Artemis, with Orion and what it's going to do. I look forward to their flight. I hope it happens sooner. It was supposed to fly, I believe, in December. It might be January or February now before it flies. I'm not sure, but, with Lockheed Martin, taking over the facility on State Road 405, where they're going to be doing a lot of that work, with Orion. And of course, we have Boeing out in Michoud producing the center section for that. So there's just a lot of work going on that, hopefully will get us back to the moon. I think that's a good stepping stone, go on to Mars. I hope I see that in my lifetime, that we're actually sending people out.
Exciting time. Exciting time
to be on the Space Coast for sure.
And as executive director of SpaceTech, you're poised brilliantly to help all of these space companies.
Well, it's interesting. Before we took on the apprenticeship program, very little of the work that we did was in Florida. In fact, it wasn't even in our business plan.
Really?
To be honest with you. Most of the work we did was outside here. We do a lot of work with the military, especially. They're probably our biggest customer, but we do a lot of work with standards organizations like ASTM International and Society of Automotive Engineers. We do credentialing for both of those entities. So that's really what our focus has been since the SpaceTech grant concluded in 2017. We kind of had to move. There wasn't a large enough pool of space business for us to sustain what we have. So we had to move into a different marketplace. And that's the board of directors at SpaceTech. These are wonderful people that, their advice and consent is essential to where we're going.
And they are movers and shakers in the business too. You've got one heck of a board of directors, for sure.
Yep.
I've met some of the gentlemen and women involved, and very.
Yeah, I'm thrilled to be working with them, as we continue doing what we're doing, and I think we're in pretty good position now to continue for a while.
Well,
and I have to give a shout out to the American Space Museum too, because Karen and is the reason we're here in Titusville, because as we were discussing partnerships and how we could work together, it was noted that there was a facility here in Titusville that could potentially serve as an office space, and so we forged that partnership and we moved over here, and it's been just an upward trajectory ever since.
And Steve's talking about Karen Conklin, our executive director, the last 4 years, been passionately involved with this museum the past almost 20 years of her life. And what do you think about our museum, Steve, and the passion that you see in our volunteers and employees?
Oh, this is a trip down memory lane for anybody that's worked, space programs. But for those people that just really want to understand, where we are and where we came from, this is the place to come. This is really cool.
And where we're going with great partners like you, showing the how young people out there can better their lives by getting involved in the space industry or the aerospace industry. I'm always just amazed at all of the airplanes flying every day. Some used to be like 5,000 commercial jets every morning in the air. And knock on wood, it's been a long time since we've had a very bad air disaster. And I think that's a credit to companies like yourself that are making sure excellence is always maintained in these risky.
Well, there are very few companies that do performance-based credentialing, and that's really our forte. And this came out of the NASA programs. NASA required technicians to demonstrate they could do the work to become certified to do it. And when Dr. Kohler built this program, that same robust practice was rolled into SpaceTech when SpaceTech was created. And this is what allowed the Office of Commercial Space to come in and take a look at it, issue us a safety approval, say yes, the programs that you have, meet the requirements for supporting especially reusable spacecraft, like we see now with SpaceX and hopefully Blue Origin soon, Boeing CST, when they finally get that off the ground, and we hope that's coming soon too. So what we do, there aren't a lot of companies that do that. It's difficult to do. It's easier to produce a computer-based test and administer it than it is to develop a team of qualified individuals that actually administer the performance testing piece. But we have a network around the country of qualified administrators that do just that. These are individuals that we contract with to administer the performance piece, and we'll continue to follow that path because high-value equipment requires a demonstration of competence. Otherwise, you run the risk of product damage, personnel damage. There's just a lot of reasons why the individuals that do that work, you need to ensure that they have those capabilities.
Very, very interesting. We've been talking with Steve Kane about the careers in the space industry. Is there something I haven't asked you, Steve, that you'd love to share with our Stay Curious viewers out there on Twitch, YouTube, and Facebook?
Well, what I would say is if you're interested in a good career, take a look at the aerospace industry. There's a lot of opportunities, not just here. There are areas all around the country that are doing a lot of work. North of Grumman in the Salt Lake City area, north of Grumman actually up at Wallops, in Virginia, here at the Kennedy Space Center, Michoud in New Orleans, up in Huntsville. There's just a tremendous amount of work going. At Wichita is another one. So there's just a lot of areas that a person can find a really good career. But just like with when I started my career, you really need a skill. And, I obtained mine in the military, which allowed me then to move beyond that. But apprenticeships, any kind of work-based learning is the way to go because you need the skill set to do this work.
Well, thank you, Steve. Been very, very interesting here, and we've enjoyed everybody. Hope they've enjoyed everything on the program today to Stay Curious. If you've been wondering what's been fluttering back here, is I keep forgetting to put up the basket that we're raffling off. Steve, look at all these Apollo goodies. This is our Apollo basket.
That's
that we did have a little hiccup in August where we closed the museum for a couple weeks. But every month we want to give away a basket of space memorabilia. $5 on PayPal. You can get a ticket and we'll fix you up and have a drawing later in October to give this away. We've had a lot of guests in our museum now getting their $5 raffle ticket. There's a shuttle bear in there, Apollo 11 patch, some Apollo 11 swag. There's a pennant from the Kennedy Space Center in the 70s. We got a hat there, over a couple $100 worth of gifts in there. We've got a shuttle a plate and so forth. So there you go. Apollo Legacy basket there. That for $5, the raffle, you can go to our website and contribute through PayPal your $5 or get multiple tickets and we will ship it to you or find ways to get it to you if you win it on there. So thank you for reminding me of that. And Thursday, we will catch up on some space history with Marty, Jessica, and myself. And then Friday, we'll have Triple T sitting right where Steve Kane was today,
Travis.
telling you some stories from the White Room. So until we meet again, under our starry skies and our spacious skies of outer space, we appreciate Steve being here and all of our staff for supporting our program here. And we'll be back with you tomorrow to bridge the space between us. Until then, I'm Mark Marquette, hoping you'll stay curious.